Okay, so let's look at a few questions just to see how well we remember. And again, you're going to want to practice recalling this information. So practicing questions, making up your own questions, just practicing recalling the steps of certain processes is going to help you master this material. All right. So all exocrine glands secrete their products onto body surfaces or into body cavities via ducts. Good, ducts, correct. Okay. Let's look at another one. Good. So which term indicates apical and basilar differences in epithelial surfaces? That was polarity. All right, polarity. All right, that idea that cells are different at the top from the bottom from the lateral surfaces. Let's look at one more. Okay, C. So to avoid ambiguity, stratified epithelia are named according to the shape of the cells at the apical layer. That's correct. Okay. Although we said that the cells at the bottom could be different. Okay, so we're going to move on to talk about the skin, the integumentary system here, and we're really going to focus on the layers of the skin, right? The hypodermis, which is not really a part of the skin, as well as the appendages, such as the oil glands, sweat glands, and some other components like the skin pigment. So the skin is the largest organ of the body, right? It covers your entire outer surface, bless you. And the skin actually accounts for a significant amount of our body weight. So if you take away the bones and the muscles and all the water, the skin is 7%. That's quite a lot of our body weight. Okay. Now it's going to vary in thickness from one area to the other. All right, it's going to be 1.5 millimeters in thinner areas like the skin on the face is quite thin. The skin at the anterior surface of your elbows is quite thin. Right, the skin behind your knees is quite thin. To thicker areas such as the palms and the soles and the skin on the back, which are like 4 to 5 millimeters. Okay. Now the skin is divided into two distinct layers. There's the epidermis and the dermis. And this we spoke about before. The epidermis is the epithelial layer. The dermis is the connective tissue. And then beneath the dermis is a third layer, which is not, strictly speaking, not a part of the skin, but it's important in adhering the skin to the underlying structures, such as the muscle, and in some cases, the bone. Okay? But bear in mind, it's not a part of the skin, strictly speaking. So the skin has quite a few important functions. Most important is going to be protection. It's going to cushion the internal organs, as well as prevent against chemical damage to those internal structures. If a chemical spills on you, it will probably abrase or, hurt your skin, but not necessarily damage anything important like your blood vessels or your underlying tissue. That'll really heal and regenerate pretty quickly. It's also going to prevent against water loss and against UV radiation from the sun or sunburn. The body temperature is also regulated by the skin. So there's some capillary networks in the skin that are going to regulate how much heat is lost via constriction and dilation. So if you're feeling hot, okay, they're going to dilate. They're going to send more blood to the skin. And that's how we're going to lose some of that heat. If you're feeling cold, they're going to constrict or close down, and they're going to preserve heat around the internal organs, and that's going to warm you up. Okay, so the regulation of the body temperature happens in the capillary networks of the skin. Excretion. So the skin is going to release through sweat, urea, ammonia, and some salts. So some of the waste products are released in sweat. And that's why if you've ever tasted sweat, it's a little bit salty. Okay, so we lose some of those excess ions in sweat. It's also going to be important in synthesizing vitamin D. All right, so persons who live in colder climates or darker countries tend to have an issue with vitamin D deficiency because the sun is needed to catalyze that conversion of vitamin D in a way that we can use it. And lastly, the sensory reception. So again, very important for us to be able to differentiate hot, cold, sharp, and all of that can happen through the tactile ability of the skin or the sensory ability of the skin. So this image is highlighting both of those layers that we spoke about. So the superficial epithelial layer, and then the underlying connective tissue, which is the dermis, epidermis and the dermis. Now we can see here that the dermis is really where the magic is happening. That's where the blood vessels are, right? That's where the nerve endings are and the sensory fibers. That's where the eccrine sweat glands are producing sweat. We got the hair roots. We got some sebaceous glands, which are producing oil or sebum, as well as the erector pili muscle, which are going to contract when we're cold, and that's how we get goose pimples or goosebumps. Okay, then underneath the dermis is the hypodermis, which is mainly filled with fat, and that's going to be an insulating layer. Okay, not very functional. So we have the epidermis, which is the epithelial layer, the dermis, and then the hypodermis. And the dermis is going to be very important to supply the epithelial layer with blood. Remember, we said it was avascular, so it does not have a blood supply. It's going to get its nutrients through diffusion from that underlying connective tissue or the dermis. Okay. So now we're going to really differentiate each of the layers of the epidermis, and we're going to go through them one by one and talk about the structures and the cells. But before we do that, we're going to talk about the 4 main cells that we see in the skin. And I'm going to point out the layers that they're found in here, but as we go through each layer, I'll point them out again. So there are keratinocytes, and these cells produce keratin. Keratin is that fibrous protein that we talked about before that is deposited in the skin, and it gives it a rough resistance against external environments. And the keratinocytes, which are located in stratum spinosum, secrete or make this protein. Then there were melanocytes, and melanocytes are in the stratum basal, or the basal layer, the deepest layer of the epidermis, and they are going to secrete the pigment that gives the skin its color. Okay. Then there were tactile epithelial cells, and these cells, I'll point them out here, right, they're going to connect to the underlying sensory nerve ending. So the nerve ending that's coming up from the dermis, this is the dermis, is going to reach up to the stratum basal, the deepest layer, and it's going to touch a tactile epithelial cell, and that is going to be how we appreciate tactile sensation. And lastly, there is the dendritic cell. The dendritic cell is found in stratum spinosum as well, and it's a part of the first line of defense in the immune system. So it's going to be acting like a macrophage, and it's going to go around and engulf bacteria or viruses that can be found in the skin. And as a result, it's going to be a first line of defense against any type of pathogen. Okay, so these are the 5 layers, and again, we're going to go through them one by one. But they're all mentioned here from deep to superficial. There are a few nice mnemonics to help you remember them. One is, come, let's get sunburnt, or come, let's get some bears. All right, so there are a few different mnemonics from superficial to deep or deep to superficial. Those are the 2 that I can remember right now. But we are going to discuss them from the deepest layer, stratum basal, to the superficial layer or stratum corneum. All right, so stratum basal, again, is the deepest layer of the epidermis, so it sits right on top of the dermis. Okay, and it's going to help to adhere the epidermis to the dermis. In this layer, we have cells that are actively dividing, right? So they're close to the blood supply. So they're actively dividing by mitosis to create more cells, which can rise to the top and carry out the various functions. There are two main cells found here, your tactile epithelial cells, again, which are connecting to those sensory nerve endings from the dermis, as well as your melanocytes. Okay, and your melanocytes are secreting the pigment melanin. And we'll see that melanin actually is a protective protein that covers or shields the nucleus of the keratinocytes. Okay. Then we move up to stratum spinosum, also called the spiny layer, And the two cells here are your keratinocytes and your dendritic cells. And it's called a spiny layer because when we prepare this layer histologically, when we prepare the skin histologically, the outer projections of the keratinocytes give it a spiny projection or a spiny appearance. Now, there are going to be some filaments in this layer called tonofilaments, right? Tonofilaments, and these are made of a protein called prekeratin. And prekeratin is essentially what gives skin its resistance to tension or its tensile strength. Okay, and this is in the stratum spinosum. Again, this is the thickest layer, right, comparatively. And it's made of keratinocytes and dendritic cells. Okay. Next is the stratum granulosum. And this is a smaller layer. And this is where the cells, again, it's a few layers, about 2 to 5 cell layers thick. The cells here start to get flattened or smushed, okay? And the keratinocytes have two important granules. They have the keratohyalin granules, and these are going to be important in the formation of keratin. Again, that protein that gives skin its rough texture, as well as lamellar granules. And lamellar granules are going to secrete a molecule called a glycolipid, and that is going to give skin its waterproof ability. Right? This is going to make skin waterproof so that we don't lose fluid easily. And at the same time, if you put water on the skin, it doesn't absorb. Right? The skin is waterproof because of the glycolipids secreted by the lamellar granules. Okay? Now, above the stratum granulosum, things get a little bit different in terms of the structure of the layers. So at this point, they're a little bit too far. So this is stratum granulosum. Okay, this was that large spinosum, and this was basal. Now, granulosum is too far from the blood supply, so what happens here is the cells begin to die. Okay, so from this layer upwards, it's all dead cells. So when you look at someone, essentially, most of what you're seeing is dead. Okay, that's all dead cells. And that's just because they're too far from the source of nourishment. Next, there's stratum lucidum. And stratum lucidum is called that because it appears clear on histological staining. And stratum lucidum is only found in areas with thick skin. So we only see it in the palms and the soles, right? The palms of the hands, the soles of the feet. And it's going to be, again, another flat layer of dead keratinocytes. So essentially, everywhere else in the body, with the exception of the palms and the soles, has 4 layers. And the palms of the soles has the additional stratum lucidum, which gives it 5 layers. All right, any questions so far? All right, and lastly is stratum corneum, And stratum corneum is essentially what is going to change in thickness. That's going to have that, that's going to cause that variation in skin thickness from region to region. I'll say that in another way. So the layer that's really going to determine how thick skin is stratum corneum, as well as the presence or absence of stratum lucidum. Okay. So stratum corneum gets thicker in thicker areas, such as the skin on the back and the palms and the soles. And again, it's a thick layer of dead keratinocytes. And what happens here is that these cells are going to start to adjust to be resistant to the external surfaces. So their plasma membrane, and we can sort of see that in this image, the plasma membrane of these cells really thickens up. And that's the way that these cells sort of toughen up as they get to the surface. Okay, they want to be more resistive against abrasion or penetration, so their plasma membranes get significantly thicker.